And then we're going back to 6.2, question 30. And then we're doing exercise 6.4.
Is your recording?
I know. Sorry. Okay. We're doing exercise 6.6, question 20 first. Then exercise 6.2, question 30. And then we're starting on exercise 6.4. Okay. A particle moves in a straight line so that displacement at time t seconds is x equals sine squared t meters. Actually, girls, I don't think this is an extension 1 question anyway. It's just a mathematics question. It says, show that the velocity is given by v equals sine 2t. So, part 1, isn't velocity equal to dx dt? Now, this sine squared t, how are you going to differentiate it? What does sine squared t mean? Sine t times sine t, or it means sine t squared. I would do it like that. So, x is sine squared t, which is sine t squared. Therefore, v, which is dx dt, is, what do you do with this 2? Bring it to the front, write out what's inside, drop the power by 1, times it by the derivative of what's inside, cos t. What's 2 sine t cos t? It's the double angle result for sine. So it's sine 2t. That's the 3-unit part of it. Knowing that 2 sine t cos t is sine 2t. That's the extension 1 part of it. That was part A of the question. This is question 20. Part B of the question says find any times at which the particle is at rest. Oh, I like this question. Well, it's okay. All right, at rest when? So find t when v is 0. So we're trying to solve sine 2t equals 0. Actually, now this is 2-unit, back to 2-unit. Right, what does the sine 2t curve look like? I wouldn't be going acute angle is, quadrants, too hard. You sketch it. So what's the period of this function? 2 pi on 2, which is pi. So it's like a normal curve. So draw it. Except this is pi instead of 2 pi. This is pi on 2. So it says find any times. So I think, girls, they're looking for find any time, so that's pi, and this one here is 2 pi. Are we okay with that? Yeah. Oh, which axis is which, by the way, girls? So I just need to move. Guys, which one's which axis? This is v equals sine 2t. So this is the t-axis. There it is. Oh, you can just see it there. That's the t-axis, and this is the v-axis. V is sine 2t. So you give me the times when sine 2t is 0. Yep, 0. Good. Pi on 2. Pi. What do you think this one is? If that's 1 pi and that's 2 pi, good. 2 pi, comma, etc. But girls, unless you can write that as a general solution, we're going to have to do this in general solution. So we're going to do it because it's good practice anyway. So how can you think of a way of writing that in a general format? If you can't, yeah, you can use general solution. Okay. So if you look at general solution formula sheet, it goes like this. Sine 2t equals sine what? It's sine alpha, but alpha in this case, sine of what is 0? What gives you 0? Yeah. So sine 2t is sine alpha. Wait, let me just bring up the formula sheet. Coming back to the formula sheet, looking for the general solution. There it is. So they've got it in that format. If sine theta is A. Okay, this is how they've got it. So they don't have it the way I just wrote it. They've got if sine whatever you've got. So I'm just going to write what they've got. Sine theta is a, then theta is n pi plus negative 1 to the power of n times sine to the minus 1 of a. So I'm just going to copy that down on the sheet. All right, that's what they've got. If sine theta is a, then theta is n pi plus negative 1 to the power of n times sine to the minus 1 of a. What's sine to the minus 1 of... See, that's how we used to do it. So it'll be this. What's theta? We've got this. Sine 2t is 0. So what's replacing what? Theta is 2t. So 2t is n pi plus negative 1 to the power of n. What's sine to the minus 1 of 0? See, 8. Yeah, it's 0. Sine of what is 0? That's what it's asking. Times 0. Well, you're lucky. We've lost that. So therefore 2t is n pi. So t is n pi over 2. Now, we probably could have seen that there. Because when n is 0, look what you get. Where n is... I wouldn't be putting plus or minus 1 because there's no negative time. Where n is 0, 1, 2, 3, and so on. So the general solution is that t is n pi on 2. If you could have done that from here, see how you got the pi on 2s? This is 0 times pi on 2, 1 times pi on 2, 2 times pi on 2, 3 times pi on 2, 4 times pi on 2. So if you see that, then you could have done it that way. Or you use the general solution, gives you all the solutions when velocity is 0. Okay? Or, yeah, or even just writing it like that's good enough. You can see them all anyway. Look, 0 pi and 2 pi, 3 pi and 2, 2 pi. But I thought we'd do a quick revision of the general solution anyway while we were there. Always do it the easiest way. We know that v is sine 2t. Find acceleration when t is pi on 6. It's just 2 units. Acceleration is dv dt, which is what? Differentiating that. How do you differentiate sine 2t? Differentiate sine, you get cos 2t times the derivative. So it's 2 cos 2t. Remember, you've got the formula sheet. Please do not, if you're not sure of the formula, look it up. And even if, just make sure you really know them. Every time you get something wrong, it's a loss of a mark. So when t is pi on 6, the acceleration is 2 times cos 2 pi on 6, which is 2 cos pi on 3, which is cos of 60 is, yeah, 2 times a half, which is 1 units. What's what? Well, it's normally meters per second per second. Meters per second per second. Are we in seconds? Yeah. Time is in seconds. So x, displacement's meters. Velocity is meters per second. Acceleration's meters per second per second. Meters per second to the seconds to the minus 2. Because you're dividing the velocity, the speed. Speed is like kilometers per hour. Meters per second in this case. Dividing it by seconds again. Because it's whatever velocity is over time. Dividing it by time. So if you've got meters per second divided by time, it's meters per second times 1 on second. Do you get it? Meters per second, velocity divided by time. Change in velocity over change in time. That's what acceleration is. So it's meters over seconds squared, which is ms to the minus 2. All right, that's the end of that question.